All right, welcome everybody to the Agile series on valuable topics related to business project management and AI. Today I am hosting Massimo Casinelli on the presentation related to float mapping. So imagine the large infrastructure like building the metro with a project cost of over than 6 billion euros.
Yeah.
And if you imagine that, you definitely picture that in projects like that, the right hand rarely knows what the left hand is doing. Everything is mismatched. The project is delayed and many invisible delays are causing red flags and huger risks than we could anticipate at the beginning of the project. So I found this article of Massimo Casinelli on float mapping, and I was amazed to the level of the visible data it was able to bring for the invisible delays. So won't keep it longer. Massimo, feel free to introduce yourself, your finding tool, and let us know more about how you managed the project at such a large scale.
Yeah. So thank you very much. Okay, I'm an Italian citizen. I'm living in Italy, and I worked in the past in the Middle East, in Turkey, in Egypt, and UK as well. So I work as a freelance advisor. Usually, I'm hired by different kind of company, owners or construction company, and I help the company in implementing project control system and project management procedures or project management of specific process targeted to improve the capability of the company to keep the project under control. The presentation is just organized in three parts: importance of float management, the presentation of a case study, and the conclusions. I will try to reach the conclusion and to in such a way that we have time to discuss about, to exchange our opinion and to specifically see which are the most important, let's say, conclusion of the approach. Why total float management is important? Because we need to understand how the float is distributed across the critical and subcritical path. Then we need to monitor float consumption, tracking how delays erode the float managing to identify potential risk, because we should be aware that we have a dynamic situation. So the total float values, they can change continuously during the project execution. Consequently, we should be in the position to adjust our scheduling strategy, because using float information allows us to take informed decision, and we can manage better, for example, the resource allocation, how to concentrate specific resource, because a specific group of activity are becoming more critical than we expect, and so on. So we need a system we need a tool to monitor this kind of evolution. But there is another important concept regarding float management, which is the float ownership. I want just give some description regarding this aspect. The float management, of course, is linked to the ownership of the float. So the question is, who owns the float in a project? So float ownership determines which party, the contractor, the owner, or both, has the right to utilize available float within a project schedule. This concept is often debated in large projects, especially when the delay arises. And I must say that few contracts clearly state which is the float ownership. In the major contract that I found, the contract was silent regarding the float ownership, and I think this is wrong because especially on large project, the contract should clearly state how the party can manage the float. In other terms, the contract should specify who owns the float. So basically, we have three models. The first is the contractor controls the float for internal risk. In the opposite, we have that owner reserved the right to use the float, for example, for change or for other risk which can affect the project. The other model is a kind of a sharing between the two parties. So, and it's called collaborative usage as a project reason. So the float became a common project resource. Float management can...
So, Massimo, one question on the previous slide. On the previous slide. Now, this you're talking specific to construction, correct?
Yeah.
Okay. So why would the owner be involved in the float? Because if I'm building it for somebody, in this case, since I don't know the business, it's more a clarifying question. Why would the owner be interested in the float?
Because, for example, the float can be interested in the float because there can be, for example, change instructed by the owner. Okay. For example, specific change could affect the milestone or the critical path. And in that case, the owner should say, okay, I'm using the float, so no extension of time is needed because I'm using the float. But in the converse, the other part say, no, hold on, just a moment. You are using float, but the float is mine in the meantime. So why are you using the float? Because the float, maybe it's for me, because I will cope with the bad weather condition, or maybe I will be in other position like delayed material or delay of equipment. And so the contractor say, okay, I can use the float because the float is mine.
Yeah, and the reason I asked the question is because if I am constructing a house or whatever, right? You have the blueprint, you agree on the blueprint, you start building, right? Now, for the weather changes, any contractual changes, zoning changes, whatever that thing is, the contractor can use the float. But if I, as the owner, go and make a change, why? Because to me, again, since I don't know the business, so don't get me wrong, right? So why would me, the owner, use the float? For me, it is a change. I'm looking if I'm paying more money or not. You see?
Yeah, for change, yes, for change we can debate because the change, of course, is a specific matter. Change affect change of scope and so scope,
right.
and this is, of course, must find a solution in a contract because we have implication in the contract. But let's see another case, for example, the owner can cause other kind of delay on the project. For example, let's imagine that the owner has to give a specific authorization for access to the site, and maybe that process got delayed for internal reasons which are not dependent upon the contractor.
Okay. Yeah, that makes sense. That makes sense.
That makes sense. So in specific case, the owner can say, okay, I'm using the fluid. The point is, if the contract is silent about this, the claim will be certainly the only solution between the parties, because
Got it.
no.
So you're trying to say, make it clear who
Exactly.
has authority to. Okay, got it. Thank you. Thank you.
Exactly. It seems something of philosophical, but it's it is a practical consequences, let's say.
Yeah, because I was thinking from a critical chain, that there's a concept of critical chain, which is similar. I want a similar float is, which is again similar. You buffer in time for risk management.
Yeah.
So everything is chained in. So if there is a delay, so then you use the time from the buffer to manage the risk. So this is kind of similar but different.
It's kind of similar. For example, I mean, for me, in my opinion, the third model is the most, let's say, suitable. It means float. It's a resource of the project.
Correct.
It's not a resource of the owner, neither of the contractor. So
got it.
The first use the float, he has the right to use the float. But again, if the contract is silent, a controversial matter may very quickly arise up.
Got it. Yeah, thank you. Thank you for clarifying.
You're welcome. So now let's do a step ahead regarding the float mapping. So we said that float managing is important, and float mapping can help to manage better the float, but also to better control and monitor and track the progress of the project. So which is float mapping? Is a process to identify the flow distribution in the CPM network. Float mapping is associated to a specific project milestone. Each milestone or group of milestones, they can be associated to a specific level of float. And we can categorize this level of float by introducing level of criticality. For example, we can say level 0. We will better see in the next slide. But you see, I mean, float mapping is helpful, and the concept of a level of criticality became a practical way to use the float mapping, let's say. Because we can better focus on critical and supercritical path and on the evolution during the execution of how the activity can change and how specific milestone can become more or less critical the other one. So the project team and project manager, they can focus, they have a tool to focus in, better which is the at the moment, at this specific moment, which are the sequence of activity, which are the problem, the topics which are affecting better the project. So float mapping can be important because enhance the project planning and control, provide a clear understanding of flow distribution, and this gives more confidence during the project planning, because float mapping became a kind of a parameter that people can discuss during the project schedule preparation, and we can better align the knowledge regarding the project schedule using the float mapping. Of course, to be realistic, float mapping needs a robust critical path logic network, because if we don't invest in planning, if we don't get very strong CPM, of course, the flow distribution cannot be realistic. So we should invest in the preparation of a CPM network.
So Massimo, pardon my ignorance. When you say CPM network, it's a tool?
No, CPM is just a method. It's critical path method. It means
Okay.
it's
Yeah,
just
I know that.
Yeah, it's just the way usually in any. I mean,
No, I know what is critical path. I thought
I
CPM
mean,
was a tool. Yeah.
in many contract there is a specific requirement that that program or schedule must be prepared by using a CPM logic network.
Yep.
Of course, in this specific project, I mean, I work with Primavera P6 because it's the most advanced tool for planning and for project controls. So level over criticality. So what is it? It's a structured framework to assign criticality levels based on float values. They help to prioritize milestone and allocated resources, enhance clarity on a critical and subcritical path, and improve risk identification and decision making. On this project, I defined 4 levels of criticality. Level 0, of course, is the longest path, 0 or minimal float. All the activity, all the sequence of activity which fall in this group of course they are impacting directly the critical path, so they require immediate attention to avoid further delay. Level 1 is an high criticality. We have limited float, for example, 10 or 15 days or 20 days, something like that. So they need a close monitoring to maintain progress. Then we have level 2 is medium. Moderate float allows balancing and monitoring the resource allocation. Level 3 is significant float, which it means that we have flexibility in resource management. So now let's see how we can use the concept. So if we identify shift in criticality, for example, change in flows values can signal emerging risks such as delays that may impact key milestones. Optimizing resource allocation to recognize when critical path approach allows the project team to proactively redistribute resources, preventing further schedule slippage, because continuous tracking of float consumption can help avoid negative float values, reducing the likelihood of significant project delay. These are general concepts, let's say. So now, of course, the concept of a level of criticality is quite easy. The difficult is that must be adopted and tailored to the specific project. Because we need to study the project, we need to study the constraint of the project, the requirements of the contract, the stakeholders, and the whole context. When we have a clear understanding of the project, we are able to build the CPM logic model, and then we are able to identify specific level of criticality, which help the project team to manage in most strategic way the project. Of course, we have to study, we have to understand the project, and this is a collaborative effort, which can, require a lot of effort from many persons, I mean, suppliers, contractors, let's imagine a project like this of 6 billion. I mean, during the tender, I think the whole project team, I mean, we maybe 150 person work on this project during the tender. And we were distributing different kind of work. There were specific contractor in Turkey. The general contractor was in Italy. The design was in French. Another design group was based in I think in US, and so Germany for the tunnel. And so the effort, it's very high. So this specific project, the timeline of the project was 7 years, and let's imagine the peak of personnel was 5,000 personnel on site, 5,000 laborers in the most critical phase of the project. And of course, in this kind of context, plot management became a strategic way, and we need to mitigate risk which are tied to contractual key dates and penalties. Because don't forget that in this contract, each key date was linked to a specific penalty. So the contractor had to achieve that milestone according to the project schedule approved by the engineer, it means by the employees. Missing those milestones means to be subject to penalties. So because a project like this, I mean, time is the most important, let's say, parameter, not because from the owner viewpoint. So what we did on this specific project, we identified the level 0 criticality was very, very thin, you see, from 0 to 5 days. All the activity which were linked to TBM operation and to base level of the station, both of this activity were critical. Because the TBM cannot stop the TBM progress in the tunnel. In the meantime, when the TBM reach a specific station, you should be ready with basement level of the station, because the TBM should pass over the slab. If you delay the slab, the TBM stop the operation. And this, it's a loss of money and so on. So here are the most important things. So TBM progress. In the meantime, you have to reach the level of the slab, because this was the most important, let's say, aspect of this project. That's why level 0 collect and identify those specific activities. Base level slab for TBM operation. Level 1.
So if I may ask, so essentially
Yes.
what you're saying is level 0 is mostly any task that is critical for the completion of your TBM operations, and anything that's critical. If it don't happen, everything stops.
Exactly.
Okay.
Everything which has a float included between 0 and 5 days are on that level 0. And if your program, if your schedule has been properly built, you will find in that group all the activity which regard the base level slab and TBM operation. If you find something different, there is some mistake during in the program, because this became even a way to control the sequence, the sequence.
So one more question. So now this is good. So which means in the first step was you build somebody, like you built the plan, right? And then you categorize the levels of the criticality based on the groupings of 0 to 5 days. So one question is, how long did it take to build the plan?
In this case, I mean, really, we started to have a clear idea after 4 months of study project.
Okay. Thank you.
Totally, we spent 6 months to prepare the master program and all the documents related to that. And then we went to Doha in Qatar to present the shell to the owner with the dev staff and so on. So it's like a project. So the preparation of a tender like this one, it's a project. You need a project manager, a proposal manager, you need a team, you need a program of the tender development, you see, because you have to prepare a lot of things and so.
Agreed. Thank you.
The other level 1, had a float between 6 and 15 days. This level grouped 2 different group of activity, which were the deck correction for elevated section. Because, you know, this is the whole project had tunnel and deck, because there was also a part of the metro which was not in tunnel, but in deck. So even in deck, we have a similar problem, because deck correction, we have a specific equipment for deck correction that it cannot stop. So they need to reach a specific column, and the column must be ready because they have to put to the deck and so on. But those group of activity was a little bit less critical than everything regarding TBM and base station.
So what is TBM, by the way?
TBM is a tunneling boring machine.
Okay, got it. Thank you.
I have some, I think, picture here. Okay, this is just extracted from the schedule. You see, basically the slab, and then ready for TPM overload. You see, you have a very small margin between the milestone and the slab lever and the completion of lever slab. If the activity base lever slab got a delay, they will push ahead the milestone ready for TPM. It means that the TPM needs to be stopped, which of course in the practical world, of course, it can happen. But when you prepare a plan, you cannot have a plan which have a stopping period of TPM, because we have a specific time frame that must be, let's say, respected. Another level of criticality, which I called medium criticality, was something regarding the electrical system installation in the station. Also this activity are critical, even if less critical. Here we have critical between, let's say, 16, 30 days of float. And finally, the last was a float which was above 13 days. Typically, this activity regarding finishing works in station and for example. So, immediate resource allocation are needed for level 0. Moderate oversight for level 2. Flexible management for level 3. The key concept is that is not written on the rock. This is the plan, but the plan can change. So we need to monitor how the thing will progress, because things may change, and we can have activity which are, for example, deck correction for elevated station can become more critical and can fall in level 0. So it means that our attention now should be shifted to deck correction for elevated section, which became more critical than base lead slab, for example. Just to simplify.
So one more question
it's
here.
It's very. I mean, it was very. When you start you prepare the plan and then you define this level, and when the team became aware of this definition, it became a language. It became a common language between the team, and I think can be really help to have a more strategic view on team. Even to present the situation to stakeholders or to the owner, for example.
Yeah. So one more question. I don't know. I hope the time is okay here, Aina. So one question.
I think we are more than 15 minutes.
Okay, good. So the thing is, so what happens in a case? So I know we all plan for the best. The program is laid out for the best. You come up with these level 0, level 1, level 2, level 3. Now progress is being made, and there are some adjustments, and some of the tasks change, some of the tasks add. So as you progress, so does this float levels move?
Yeah, move, absolutely, yes.
Okay.
Yes.
So then based on these guidelines, you would readjust.
Yeah, we have to adjust. We have to adjust the model.
Beautiful.
Because this is the plan.
Right.
But the things may, may change.
Thank you.
But you can use the same level of criticality, which can be different, or the activity, which may fall in different group, comparing with the original plan, for example.
Perfect. Got it. Thank you.
But in this case, I mean, the scope of this is to achieve the plan, because that plan was the best plan according to the contractor. That plan was the best plan, which was even based on contract requirement, for example, and or with constraint. Of course, any plan may change, and the project manager and the project team must be ready to cope, face with different situations. But this doesn't mean that we don't need the plan.
Right. No, agreed.
No, agree. No, but because somebody say, okay, but why should I invest so much time in a plan if the plan change? If you don't invest that much time in a plan, you will not understand the project, and you will not be able to drive your project. The project will drive you, not you the project.
Agreed. Thank you.
So here you see, this is just a picture of the TBM, which started to excavation. And that is the level 1, so the deck operation, you see. So all the activity which were converging with TBM, were linked to TBM, were included in level 0. All activity which were linked to deck operation were included in level 1. Of course, I mean, this model came from the specific project. I mean, but we can adjust the concept on our specific project, of course. So, insight for project leadership. That is what I found, and that it was my, let's say, opinion. Benefits of monitoring criticality levels. Early warning for milestone at risk, because they help this one. Patterns in fluid consumption reveal systemic inefficiencies or lack of productivity on a specific activity. And so we can monitor in a early way those loss of efficiencies.
Yep.
Data-driven decision-making for resource allocation. This is logic. This is logic consequences. What do we get? We get a greater alignment with the project of objectives. Alignment within the team is very important. Rarely the project team is very aligned during the project planning on the project schedule. Typically, there are few persons which are aware of the master schedule, and many persons are not aware. And the lack of alignment is a problem. Working this way, we got a better alignment between the project, because, as I said before, it was a kind of language, let's say. And of course, the last one, but not the least, is improved stakeholder communication, because it became a very clearly way to present the situation.
So if I may add to this, though, what I'm seeing here, you're right about the alignment, because you defined a lot of things early on, which gave, as you said, a common vocabulary for people and even the leadership.
Yeah.
So beautiful.
Because this helped the project manager. Project manager. I mean, one of the typical problem of project manager is lack of a knowledge alignment within his team, because there are specific issues, and the key personnel project team, they should be aligned on the problem, on the progress, and so alignment is important. Alignment means that we have the same way. We share an issue, we identify risk, we share the knowledge and the action that we plan for those risks, and everything linked. So it's very important for practical project management actions.
And Massimo, if it's okay if I jump in, I just want to emphasize the importance of alignment with the stakeholders and early communication and risk alignment as well, because many in my presentations are focusing on budget constraints, time constraints, and saving up the cost, which is important, which I think you did at the end of the project. But how we are saving up this cost and minimizing the timeline is by proactively communication with stakeholders and proactively getting their alignment. So we are not wasting time of alignment with people, and so that's how we are cutting off the costs and saving time, and generally speaking about the project. So thank you.
Yeah, definitely. So just to conclude, I mean, fluid consumption became a key indicator of delay, of course. Importance of tracking fluid consumption. Why? Because detect early delays on non-critical path. When we observe that specific path, they are changing the flow. So the flow is reducing. That means that we are getting delays. Those delays are not yet impacting critical path, but they will if we don't do anything and if we don't take a specific action. So detected early is important, because we can take action to maybe to mitigate or something like that. Assess transition of flow to negative. Of course, when the flow becomes negative, means that we are impacting critical key milestone. means that we are going to suffer of penalties, because if float became negative, it means that we got already in delay, and we have to recover that delay. Of course, it's important because this activity, I mean, support corrective action with data-driven insight. We can also, for example, prepare a trend chart. I like disruption and resource overlapping. I mean, because starting from this data, we can also make, let's say, build a specific chart, a specific graph now to better present the situation. So I want just be a little bit more faster on this one. Okay, I mean, during the project, so during the tender stage, we improved the schedule transparencies. I mean, because, you know, working this way, as I said before, helped the team to become aware of the common and critical issues which were affecting. We have the typically on that project. But there is another aspect which are important, because I mean, this activity to mapping the flow, the level of activity, this activity helped us to better risk simulation for a quantitative schedule risk analysis. Because the contract called for that preliminary schedule risk analysis even during the tender phase. And of course, anybody which, you know, is if somebody has a specific practical experience of quantitative schedule risk analysis, I mean, they understand that modeling is the most important thing. If we know the milestone, and if we know the range of float of specific milestone, we can better model and simulate risk analysis modeling by using specific software and so on. This was certainly, I mean, certainly, if the contract asked for a quantitative schedule risk analysis, I think definitely I will suggest the way to follow this way. Of course, quantitative schedule risk analysis help to plan cost contingency, of course, because when we build the budget, and if we perform a quantitative risk schedule risk analysis based on a strong CPM model, we can define more realistic values of contingency. What about during the execution? Early detection of delay, dynamic adjustment of resources, productivity analysis for claim and compensable delays, of course, even earned value management can better be performed if we know those kind of values. So, conclusion. Key takeaways. Let's see. Float mapping enables clear identification of risk areas. Risk are as described by the contract, and linked to the specific project. Categorization of milestone through the level of criticality, enhance planning and resource allocation. Strategic overview empowers project leadership for better action. Strategic benefits, according to my opinion, are identification of maneuvering margin for unforeseen events. You know, we are more ready to face with unforeseen events because we have a kind of a tool, a system which can help us to take better and faster decisions, more informed decisions. For key example, TPM passage, no? I did the example of TPM operation, the bridge segment erection. Those are specific key milestones, and we should know all the risks which can impact those specific activities. This is the knowledge on the project. If we can link risk on a specific phase, on construction phase, and on specific milestone. And this approach of float mapping with the level of criticality, I think, can help and can give us this better. So I believe it is a replicable framework. Future application, I think, certainly is a model for complex project. I mean, because no, it's clear. Clarity in criticalities and risk identification, strategic monitoring for schedule optimization. I mean, all those activities, I mean, can be implemented better and can be improved better working by using this model.
And I apologize for interrupting. We just have 3 minutes left, and I have a hard time of
I think it's finished because the last one is important. That is the float mapping, a quantitative schedule risk analysis. I describe it with why float mapping can help quantitative schedule risk analysis. That's it. I think it's finished.
Thank you, Massimo, and thank you, Tom, for raising the questions. We have other people on the call, so I just wanted to give a few minutes to interact with the speaker and to raise questions if people do have them. Thank you, Christian.
This was good.
Thank you for joining, and thank you all for staying with us until the end.
Thank you, Tom.
Yeah, but Massimo, thank you for sharing your experience. This was beautiful. So much appreciated. Thank you. Yeah, sure. Take care.
Yes, thank you so much, Massimo, for joining, for sharing. It's a fantastic case study. It's very rare to find the case studies with a scale like that, because normally people talk about way smaller projects. So thank you very much for sharing and for sharing this method, which is kind of like similar to classic project management, but different with some twists and adjustments. So something to consider about in our day-to-day work as well. So thank you again. And thank you, Tom, for being interactive, for raising questions. So I just stayed and enjoyed your conversation. Very much appreciate you both.
My pleasure. Thank you very much to you. It was a pleasure.
Take care. Yeah.
Goodbye. Thank you.
See you soon.
Bye.
Bye.